Hi, welcome to Francois Maths class. Today we are going to look at the topic coordinate geometry 1, which takes care of the straight lines. And with this it deals with lines. And when you look at lines, it starts with a point. And when you talk of a point on the plane, any point on the plane can be described as an ordered pair, which takes care of the x-axis and the y-axis. So we are going to consider, first start with finding the length or distance of a straight line, or length or distance between 2 points. Length or distance between 2 points. So with this, when you have this is your plane, having your y-axis and your x-axis. So let's look at the line or the distance of from A to B. So we are now going to look at how we can find the distance between these 2 points, A and B. So this point, let's consider we have x1, y1. Then this point, let's consider we have x2, y2. So this side, in a way, becomes our x1. Then this side gives our x2. Now the same point, when you consider the y-axis, this side, we have our y1. Then this side gives us our y2. Now, if you want to know the distance between x1 and x2, it's like having 2 here and having 5 here. If you want to know the distance between that, it means you have to subtract the 2 from the 5. So it means if you want to get the distance from here to here, it means it's from x2 minus x1. You have to subtract this one from that. The same thing applies to this side, which is our y1 and y2. If you want to know the distance between y1 and y2, it means you have to subtract y1 from y2. And that one gives you the y2 minus y1. But if you look at this, this gives an angle of 90 degrees. And we want the distance of A to B. And finding that, it means we can apply the rules of the Pythagoras theorem. The rules of the Pythagoras theorem, which states that the square of the longer side, which is the hypotenuse, is equal to the sum of the squares of the other two sides. So with this, we can say that AB squared is equal to, now the distance from here to here is x2 minus x1. So x2 minus x1 squared plus then this side, which is y2 minus y1 squared. So if you want to find the distance of AB, then it means you have to find square root. So the distance AB is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. And this is the formula for finding the distance or length between 2 points. Let's use it to solve some examples. So the first example, 1. Find the distance between the points P, 2, 5 and Q, 5, 9. So we are asked to find the distance between the points P, 2, 5 and Q, 5, 9. So with this, we know our P is 2, 5 and our Q is that. So let's look at the P, 2, 5. So let's this one be our x1 and this one be our y1. Then the Q, 5, 9. So x2, y2. But from the formula, we have PQ is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. So now we can substitute our various values, having our x2 is 5 minus x1 is 2 all squared, plus our y2 is 9 minus our y1 is 5 squared. So we have square root of 3 squared plus 4 squared. So this one gives us square root of, this one will give us 9, this one will give us 16, and that will be 25. So the answer becomes 5 units. So the distance of P and Q is 5 units. 5 units. Let's try another question. Another question. Let me use this part. Find the length of the line joining the points A 1 3 and B 4 7. We are asked to find the length of the line joining these points A and B. So the same procedure, A 1 3, which is x1 y1, B 4 7 x2 y2. So AB is called square root of x2 4 minus x1 1, which is called plus y2 7 minus 3 y1 squared. So with this we have 3 squared plus 4 squared. Coincidentally, we are getting the same answer as, because we have 9 to root 25, and the answer is 5 units. The answer is 5 units. But sometimes you have to apply this one when solving a particular question. So let's look at a question where you need to apply this one to solve. The question is S 4 6 and R 12 6 are points on the Cartesian plane. A point P x y moves such that PS is equal to PR. Find the equation of the locus of P. So that is our question. S 4 6 and R 12 6 are points on the Cartesian plane. A point P x y moves such that P, the distance of Px is equal to the distance of PR. Find the equation of the locus of P. So with this, it means we are going to apply the distance. We've been given P to be xy, and we're given S to be 4 6, and R is 12 6. But from the question, PS is equal to PR. So with this, we have to find the distance of PS. So let's have PS is equal to, these are x1 and these are x2. So we have square root of x minus 4 all squared plus y minus 6 all squared. Then we have PR. The same way we pick this one and that. X minus 12 all squared plus y minus 6 all squared. But from the question, they are equal. So you equate this one to that. So P, which is x minus 4 squared plus y minus 6 squared, all with the square roots, is equal to square root of x minus 12 all squared plus y minus 6 all squared. So having that, the first thing you have to do is you square both sides. So when you square both sides, the square root will go. Going to cancel both square roots. So x minus 4. But we can open this side. When you open this, I have x squared minus 16 minus 8x plus 16. That's x minus 4, x minus 4. Plus, we have y squared minus 12y plus 36 is equal to, then you open the side to x squared minus 24x plus 144, or 12 squared is 144, plus y squared minus 12y plus 36. So that is the expansion. After expanding, we can begin to group some of them. But let's look at them. With this one, when x comes here, the x squared will cancel out. So this and this is gone. The y squared is gone. 12 negative 12y negative 12y, when it comes here, the plus, so that one is gone. Then plus 36 plus 36 is gone. So it's left with this side. So negative 8x plus 24 is equal to this one. Also join this 144 minus 16. And this one, you are going to get 16. There's x here. So 16x is equal to, this one will give us 128. 128. We want x. So what did we divide both sides? So 16 here by 16. Therefore, our x will give us 8. Our x is 8. So the locus of P is x is equal to 8. The equation of the locus of P, the equation of locus of P is x is equal to 8. And that gives us solution to this question. All right, we come to the end of today's lesson. Continue to subscribe to Francois Maths class, and you can also contact me on my WhatsApp contact 0246 426343. Have a nice day and bye-bye.